Greetings, math fans. All right, so today's lesson is called Law of Cosines. And we've already studied law of sines. So let's just kind of review because you need to know when to use law of sines and when to use law of cosines. So using law of sines, we've already talked about this. Remember, that's when you had angle side side, and you had angle side, or also angle side angle. Those are really the same thing, right? If you have two angles, you automatically have the third angle. So that is how you use law of sines. And remember, the reason we use law of sines for that is because if you had angle side side, you had an opposite angle and side. Same thing with angle side. Angle side, you could figure out the other angle, it doesn't matter, but you had an opposite angle and side. But now what we're going to do is we're going to do something where we have our given side angle side or side side. And just to kind of sketch it over here, just think about it. If I give you side angle side, you have no opposite ratio, right? I don't have anything opposite an angle or side to make a ratio, so I can't use it. Same thing with side side, right? You don't have an angle opposite it to set up a ratio and use a proportion because you would have two missing variables. Okay, so you're going to use law of cosines when you have side angle side side. You really can't make a mistake. You can't accidentally use the wrong one because you won't have enough information to use when using the wrong one. It just won't work. Okay. All right. So let's get started here. Let me kind of erase this stuff on top here, and let me basically tell you what the law of cosines is. Now, I've already derived it, and you can see it in the previous video. You can watch law of cosines, so I'm not going to do that. I'm just going to actually write the formula. We're going to talk a little bit about it. So it's a squared equals b squared plus c squared minus 2bc cosine of a. Okay, so that's using a, and let's just do I want to do two more just so you guys get the idea of what the equation really looks like. So it's b squared equals a squared plus c squared minus 2ac cosine of b. Now I want you guys to notice, math fans, that here it is. Here's side A and here is angle A. So those go together. Okay, and we have the other two sides, B and C, and then we have B and C again here. Okay, so if I ask you what c squared is, you guys should be able to go, oh, it's the two missing sides, so it's a squared plus b squared minus those two times ab cosine of, well, angle C. Okay, so that is that's the law of cosines. Pretty easy. Let me talk about, before we actually do any kind of problem here, I want to talk about the common mistakes. All right, and we'll just use it on this one example below here. The common mistakes, and it's so important you guys write this down. The common mistakes, you guys are going to even laugh at this. One of the most common mistakes is it's a law of cosines, and kids use sine there. I don't get it. So they do the whole problem. They have sine there. They completely get it wrong because they use the wrong formula. They don't even use the law of sines. They just use sine where it says law of cosines. Okay, so that is when kids use sine. That's a mistake. So don't do that. Another common mistake is kids forget to take the square root. So don't forget to take the square root after once you get c squared, you take the square root to get c. And then another common mistake is this guy right here, minus 2ab. Kids forget the 2. Sometimes they do addition, and sometimes they forget to multiply both of them together. This one's not as common, this guy right here, but the subtraction sign and the 2, they just go minus ab or they go plus 2ab. That's a common mistake as well. Okay, so there, and there. Those are your three common mistakes. Please don't make those mistakes. Okay, so let's actually start out with a nice little friendly problem here. And again, just like the old days, it says solve the triangle. Okay, so you're going to be given angle C is 28 degrees, side B is 6 inches, and side A is 4 inches. All right, so the first thing, and then of course you're going to find the other two angles and the one side. The first thing I want you guys to do is you need to make a sketch because you need to know what you're missing so you know whether to use the law of sines or law of cosines. So if I label this A, B, and C, and I just mark it. So all I'm asking you guys to do is just mark it, not do any, you don't have to write any numbers in there. And if I mark all that, I can see I have side, angle, side. So I pretty much know I can't use the law of sines because I have no opposite ratio here to use it. So I know I'm going to use the law of cosines. Now, how do you know what to find first? Well, here's the deal. I'm going to actually write this out. I'm going to tell you this right away. I'm going to find C. So I get C squared equals A squared plus B squared minus 2AB cosine of C. The reason I'm finding C, math fans, is because if you look at the equation here, basically it's the two sides. This A and the B are two sides, and the C is the included angle. And that's exactly what I have here. Okay, I have the included angle, angle C, and I have the two sides on either side. That's what you're looking for, and then that's going to allow you to find C squared, or this opposite side here, opposite from the angle. Okay, so we're going to use law of cosines, and let's plug it in. So it's going to be 4 squared plus 6 squared minus 2 times 4 times 6 times cosine of 28 degrees. So we get C squared is equal to 9.62, blah, 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 keep going, and then take the square root of both sides, and we get C is equal to 3.1 inches. Now, math fans, so this is one answer. This is really, really important. Do not hit clear out of your calculator and clear this number out. You need to store this value because I'm going to be using it in future equations. Okay? And if you hit clear, you've just rounded 3.1 whatever to 3.1, and now you're going to round it again. And it's bad practice. It's bad practice in so many fields. In engineering, any of the sciences, it's so bad to keep rounding and rounding and rounding. You use all the exact answers throughout the problem, and at the very end, you round. Really, really important. Think of building a bridge. You're not going to round each board or each beam by a tenth of an inch, because if you round at the end, you might be a tenth of an inch off, and maybe you can fill it with a little more steel or whatever. But if you round it to the tenth of an inch, and you have 1,000 boards out there, okay, a tenth of an inch times 1,000 is 100. It's going to be 100 inches off, and then the cars are going to fall off the bridge, and people are going to cry. Okay, so you cannot round this number. What you have to do is you have to store it. Well, let's talk about storing your calculator. If you, I have my virtual TI here. I'm just going to actually do this whole problem because I want to do it. So it's important to know how to use your TI. So we're going to do 4 squared plus 6 squared minus 2 times 4 times 6 times cosine of 28 degrees. Don't put the degree symbol in there. Close the parenthesis, hit enter, and 9.61. Okay, so it's 9.62, and then we take the square root of it. Now, I don't even know if some of you guys know how to do that, but if I actually hit second x squared, so I take the square root, and then I want to put that answer in there. See that little negative, your negative sign next to the decimal? It's got ANS above it, so I hit second answer, and that's what it puts underneath the square root. So if I want to use that number again, that's the last thing I did. It's got answer, and I take the square root of it, and I get 3.1. Okay, I want to store that value. What you do is you hit this STO. It's right above your on key. STO, little arrow. So you hit store, and then you hit. See how next to the alpha button, the green button on top there, it says X, T, theta, and N. You want to hit that button, and that's storing it in X. Now, truly, you have 26 letters of the alphabet to store into. If you see, I could hit alpha and any one of those letters, A through Z, but why hit alpha? Why not just use the one that's really common, X? It stores it there. So if I hit enter now, it stores that number. Okay, so if I want to do 5 plus X, it should give me 8.101 blah blah blah. And there it is, 8.11. So that number, that last value is stored in X. It's really important because now we're using a non-rounded value. Okay, really, really important. So let's keep going here with what I need to do. Okay, I just want to show you a little bit on the calculator. Well, now I have a side. So once I have a side, think about it, I have a ratio now, which is perfect. Okay, and I need to find one of the other angles. I need to find either angle A or angle B. Now this is really, really important, math fans. You can find any one of them, kind of. You can't find the largest angle. The reason you can't find the largest angle, if you guys remember when I first started talking about law of sines, is because if an angle is greater than 90 degrees, law of sines will not work. In fact, it'll give you, the answer is 100 degrees, it'll actually give you the reference angle, and it'll give you 80 degrees. You cannot find the largest angle with law of sines. How do you know which one's the largest angle? Just look at the two sides. Okay, I've got B is 6 inches and A is 4 inches. All right, so that means this is going to be the largest side, or largest angle. So what you're going to do is you're going to find angle A first, and then you're going to subtract from 180 to find angle B. That's the way you do it. Okay, so again, write this on here. Don't use law of sines to find the largest angle. Really, really important. You can use law of cosines because cosine can handle between 0 and 180 degrees. That's great, but sines can't. Okay, so let's set this up. And I do want to mention too that you're only going to use law of cosines one time, and then you'll use law of sines after that, and then you'll subtract from 180 to find out the final answer. Okay, because law of cosines is a little more complicated, so why would you use it more than one time? So let's do it right on the side here, our work, and it's going to basically be let's set up a ratio, 3.1 over sine of 28 degrees. Now, by the way, this 3.1 is our x. Okay, equals 4, which is A over sine of A. So if I cross multiply, not actually multiplying it yet, but I get 3.1 sine of A equals 4 sine of 28 degrees. Divide by 31, or 3.1, sorry. Let me move this down a little bit. I'm running out of room. And I get sine of A. Now I want to multiply that out. So I'm going to do, in my calculator, I'm going to pull it up here, 4 times sine of 28. So let me move this over here. 4 times sine of 28, close a parenthesis. I'm going to divide that by 3.1, which is x. Okay? Because if you did 3.1, it's going to be off. So you divide it by x, and you get 0.6055. That's what sine of A is. So 0.6055. And then you do, of course, inverse sine. That's what A equals. You do inverse sine of that, of the answer. I'm going to even write that, answer. Okay, because again, if you round that, it's going to be wrong. So let's go back, and so it's inverse sine of second negative sine, which is answer, close parenthesis, and we get 37, and then actually if I do convert that to degrees, minutes, and seconds, (37 degrees, 16 minutes). So 37:16. Okay, so that's another answer. And now my last thing is I need to find angle B. This is important now because, again, you're not going to use law of, you can't use law of sines anyway because B is the biggest angle. So I'm just going to do 180 minus the original angle, which is 28 degrees. So I'm basically subtracting the two angles. Okay, so if I subtract all that, I get 114 degrees 44 minutes. Okay, and one thing, this is angle B. And I'll tell you, you would have gotten the wrong answer for you to use law of sines to find angle B because it's bigger than 90 degrees. Okay, really, really important you understand that. Another thing I want to point out too is please make sure all your angles add up to 180 degrees. If I take 28 and 37/16 and 114/44 and I add those up, I will get 180 degrees exactly. Sometimes what happens is kids, they mess up, or they use law of sines and they try to find angle B, and anyway it doesn't add up, and this turns out to be like a 43 minutes. You guys need to subtract from 180, and you basically subtract the rounded version from 180. It's kind of the only time you really use a rounded version because your angles have to add up to 180. So you take the 28, which was given, and the 37/16. Okay, so that's a rounded answer. But then when you add up, when you subtract that from 180, you get 44, and that's what you're going to use then. So these all need to add up to 180. Okay, so I kind of threw a lot at you, showed you a little bit about the calculator, but you need to know these things. Okay, so let's do another example here using law of cosines. So solve the triangle. Okay, so you're given little a, so cute, 9 centimeters. Little b is 6 centimeters. And little c is 8 centimeters. Okay, draw a quick picture here. A, B, and C. It's pretty easy to mark everything because it's side, 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 which is nice to label. You know you have to use law of cosines. You can't use anything else. So the first question is, what do I find first? Obviously, I'm finding an angle because I'm given all three sides. Well, remember I told you you can use law of cosines to find the biggest angle. You don't have to, but here's my recommendation. Why not use it to find the biggest angle? Because then you won't make a mistake when you use law of sines next and accidentally find the biggest angle, which again might not work out. So why not just go for this one right off the bat and use law of cosines to find the largest angle? I think it's just helpful. So I'm going to use law of cosines to find angle A. Okay, so just, if you want to write this down, use law of cosines to find largest angle. Okay, because then you won't leave it accidentally for law of sines. All right, so let's write out the formula here. A squared equals b squared plus c squared minus 2bc cosine of A. We're looking for angle A. My recommendation is you solve for angle A first, and then you plug it in. You'd be amazed on how many times I say that every single year, and kids ignore me, and when they do the work, they plug it all in, and then they divide it all out. And a lot of them get it right, but some get it wrong. I'm like, why would you not follow my directions? I've done this enough times, and I've seen kids make these mistakes. So I'm going to subtract b squared and subtract c squared from both sides. So I get negative 2bc. I'm just going to switch things around. Negative 2bc, cosine of A is equal to a squared minus b squared minus c squared. And then I'm going to divide both sides by negative 2bc. All right, so that's cosine of A is equal to that. That's all I'm looking for. And now you plug it in. So cosine of A is equal to 9 squared minus 6 squared minus 8 squared over negative 2 times 6 times 8. Okay, and after I do that, I'm going to type in an inverse cosine. Now this is really important. The thing you got to be careful about this, math fans, is you got to use a ton of parentheses. Those are the two key ones, the top and the bottom. Got to use them. Because if you don't use the top, you can see that most obvious about the top. But the bottom, sometimes kids are like, well, it'll just do order of operation. Well, actually what will happen is if you divide it by negative 2 and then say times 6, it'll divide everything by negative 2 and then it'll multiply the whole thing by 6 as opposed to still dividing it by 6 and dividing it by 8. Okay, so let's bring up the calculator. And you guys should practice this as well because kids get this wrong a lot. So we got 9 squared. Now you're like, Mr. Curtis, you're not using a parenthesis. Yeah, you're right. I'm going to hit equals at the end of this. If I hit equals at the end of this, that means it's like a big parenthesis. Your call what you want to do. The bottom, I will definitely use a parenthesis. So it's 9 squared minus 6 squared minus 8 squared equals. That's my parenthesis. Divided by, now I'm going to put parentheses in there. Parenthesis negative 2 times 6 times close parenthesis, hit enter. Okay, nice value. So cosine of A is 0.1979. So let me write that in here. Cosine of A equals 0.1979. That was a good year. All right, and then we do A is inverse cosine of that value. So I'm going to write here answer because we didn't clear our calculator. So it's second cosine, inverse cosine of second negative sine of answer, close parenthesis. And we get 78.58. I want you guys to convert it to degrees, minutes, and seconds. So we're going to hit second angle number 4. And that's going to give us 78.35. Okay, so let me write that in here. Angle A is 78.35. So now I'm going to store that in X. Store in X. Okay, so that's important because I'm going to use it again. Remember, you're only using law of cosines one time, and then I'm going to have a ratio. I'm going to use law of sines. So I have to use that value in my law of sines. That's a stored value, an exact answer. Okay, so I'm going to say use law of sines. Now it doesn't matter which angle we find. So let's kind of go back up here, or which angle I find. Right? I can. Who cares? I'm going to go with doesn't matter. Let's do angle B, because angle B is a small angle, and why not just pick always a small one for law of sines? It's just kind of friendly, right? So I'm going to get 9, which is, again, we found angle A, so 9 over sine of, and it's 78.35, but it's really sine of X is equal to 6 over sine of B. Okay, so just to cross multiply now, I get 9 sine of B is equal to 6 sine. I'm just going to put sine of X because that's kind of good. Let's move this up here a little bit and then divide both sides by 9. So sine of B, or our favorite Lion King character Simba. Let's get our calculator out here again. So I'm going to store that. I didn't do that. I'm going to store that value in X. Hit enter. Okay. And then let me move this so we can see a little bit what's going on here. We've got 6 times sine, or 6 sine of X, so we'll put X there, close parenthesis, divided by 9 equals 0.6535. So write that in here, 0.6535. Again, you're never hitting clear. Then we do the inverse sine of that, which is inverse sine of answer. So we get angle B equals, let's do that. So second sine of answer, close parenthesis, it's a good habit, and we get 40.80, so we'll convert that into degrees, minutes, and seconds, number 4, and we get 40 degrees, 48 minutes. 40 degrees, 48 minutes. Okay, so we've got, here's angle A, here's angle B, and then how do you find angle C? These are rounded values, but remember, everything needs to be added to, has to add to 180 degrees. So we're going to find angle C that exact way. So truly you're using law of cosines one time, law of sines one time, and then subtracting from 180. Okay, so we get 180 minus 78.35 minus 40.48. And so, oops, that's angle C. So angle C comes out to be 60 degrees, 37 minutes. All right. So that's one example of side angle side and side side side. Side 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 actually is, I think, more difficult because you're actually having to solve for cosine of A. That's a little more difficult, as opposed to when you find the side, you solve for A. That's a little bit easier. But when you're trying to solve for cosine of A, please solve for the variable first, like this, and then plug in values like that. Okay, that's my advice to you. All right, so that is law of cosines. There's one other thing I want to show you guys, and that is the area, a nice little area formula. So it's area given side, side, side. And this is called Heron's area formula. All right, I'm not going to derive it. Heron, I'm sure you can find it someplace, but this is what Heron's formula is. But it's given side, side, side. So what you do is first find S, and S is the semi-perimeter, which just means the half of the perimeter. Okay? And so basically in an equation, it's 1/2 times A plus B plus C. Really, really easy. And then your area formula is just this. It's the square root of S, which is the semi-perimeter, times S minus A, times S minus B, times S minus C. Okay, again, these are all, it's all multiplication right here and here and here. And that's it. So, first thing, way I want to kind of show you here is let's test it on something we know. Test on a right triangle. So if I tell you, if I give you an area or a triangle here, and it's a right triangle, and if this is a 3, 4, of course this is a 5 triangle, right? Yeah, you guys know the area formula is 1/2 base times height, right? So that's 1/2 base is 4, my height is 3, so it's 6 square units. Let's use Heron's formula. So first of all, let's go down here. So S semi-perimeter is 1/2 times 3 plus 4 plus 5. So it's half of 12, which is 6. And then the area equals the square root of 6 times 6 minus 3 times 6 minus 4 times 6 minus 5. That gives you the square root of 6 times 3 times 2 times 1, which is the square root of, it's 1836. Hey! Square root of 36 is 6. Same thing. It's a great formula. I think it's such a powerful formula that you can measure, it could be any triangle, and you can measure the sides. You don't have to, it doesn't have to be a right triangle. You can have a piece of carpeting in your home, a nice the old triangle room, and basically you can find out the area of that triangle room to get carpeting or tile just by measuring all 3 sides and plugging it into Heron's formula. That is the coolest formula. Okay? So, real quickly, we already learned this formula. We already learned the other area formula. Area is 1/2 AB sine of C. And that's if you have this information. Basically, if you have side angle side, you're going to use this formula for this type of problem. As opposed to Heron's, which we just learned, is side, side, side. All right? So the deal is here, math fans, if I give you 3 sides, please don't use this one, because then you're rounding angles, and it's just, it doesn't work out as clean. And what I've really seen, it really bothers me when people do it, is they're given this information, and they do all kinds of work to find the 3rd side, and then they use Heron's formula. And the problem is, when you find the semi-perimeter and you have a rounded answer, well, first of all, the rounded answer doesn't work. But if you try to do an exact answer and use that big decimal, and you do A plus B plus C, one of those values is rounded. So now you have, or I shouldn't say rounded, one of those values is really nasty because it's because you found the side and it's using law of cosines to figure it out, and the side is like some nasty decimal. So now you have a nasty decimal for A, and then when you do the square root of S minus A, S minus B, S minus C, you have a nasty decimal here, 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 and here. You have a nasty decimal in 5 places. I don't know if I've ever seen a kid get it right when they are using nasty decimals and they use the wrong formula. It works, but you have to make sure you use that decimal the whole way through, and kids don't do that. So think about it. If you're given a side and an angle side, the angle being between the two sides, then you use this formula. If you're given 3 sides, you use Huron's formula. I cannot stress that enough. Okay? Anyway, that is it, math fans. I just want to show you really the 2 examples in detail for law of cosines, and also Huron's formula to find area of a triangle given 3 sides. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.